Most of the bleves that you will see in this video were deliberately induced by impinging severe torch fires on the tanks. In some cases, the tank shells were mechanically weakened. The term Belve stands for Boiling Liquid Expanding Vapor Explosion. We find liquefied gas tanks everywhere around us. There are approximately 1 million propane storage tanks and 14 million refillable cylinders in use across Canada, including in our own backyards. Yet because of their sturdy construction and safe storage and handling practices, very rarely do we ever have a tank Belve. A pressure liquefied gas, or PLG, is a substance that would be a gas at normal atmospheric pressure and temperature, but it is commonly stored and transported as liquid under pressure. The most common pressure liquefied gas in use is propane. At 20 degrees Celsius, propane is maintained as a liquid as a result of being under a pressure of 121 pounds per square inch, or 834 kilopascals. At the critical temperature of 97 degrees Celsius, propane cannot be maintained as a liquid regardless of pressure. At minus 42 degrees Celsius, propane will remain in a liquid state at atmospheric pressure. If a pressure liquefied gas container fails, resulting in a sudden loss of containment and a sharp pressure drop, the result can be an explosive release of vapor and boiling liquid. That is a Belve. The Belve is a physical explosion with accompanying hazards of blast, flying projectiles, and a vapor cloud. The substance does not have to be flammable to Belve. However, if the substance is flammable, such as propane, then the additional hazards of fireballs and thermal radiation will most likely occur. A Belve is a low probability event with high consequences. It can be devastating.
Rare though it is, a Belve is among the greatest dangers you can face as a firefighter or emergency responder. Through an accident or a fire, a Belve can occur with any of these tanks. You could arrive just in time for the blast and have jagged steel projectiles flying at you. Belves can happen in places you might expect. A fire in a tank storage area, a tanker truck accident, or a tank car derailment. They can also happen in places you don't expect, where you may not even know there's a tank. For example, barbecue propane tanks, inadvisably stored in basements, sheds, or emergency stairwells.
Or you arrive at the scene of a fire in an outlying area. A barn is burning. It looks like a routine operation, but there's more here than meets the eye. Out of sight behind the barn is an LP gas tank right up against the building. This installation is dangerous. Flames are impinging on the side and top of the tank. It is a recipe for disaster. Inside the tank, the heat is vaporizing the liquid gas, increasing the tank pressure. To limit the pressure rise, the pressure relief valve goes to work. However, in relieving the pressure, the PRV also lowers the level of the liquid in the tank. The flame now impinges on the tank above the liquid level, causing the wall of the tank to heat up. The heat builds up to high temperatures, weakening the steel critically. The weakened metal under pressure allows the tank to fail. The Belve erupts with a huge fireball and thermal radiation. It sends out a shock wave and sends tank fragments rocketing. The danger zone for projectiles is the greatest. The Belve of a large tank can propel tank fragments, pipes, and other debris 1,000 meters and more.
What you've just witnessed happens quickly. The weakening of the tank shell by heat can take just minutes with a severe flame. Tank failure and the Belve itself occur in a fraction of a second. Let's take a closer look at what can happen.
Exactly how does fire cause a tank to Belve? The fire heats the tank walls rapidly and unevenly, driving up wall temperatures over the vapor space much faster than where the liquid is in contact with the tank shell. As the PRV cycles to reduce the pressure, gas escapes, lowering the liquid level still more and exposing more vapor area of the tank shell to the rising temperatures. As temperatures soar, the steel walls rapidly lose strength. Wall temperatures quickly reach 400 degrees Celsius over the vapor space, weakening the steel by 30%. Above 600 degrees Celsius, steel strength drops dramatically. By the time the wall reaches 700 degrees Celsius, minutes later, the steel has lost 90% of its strength. Under pressure, the thinned and weakened shell fails.
It's amazing how quickly steel weakens at high temperatures. That's why a tank subjected to a strong torch flame can Belve so quickly, anywhere from 3 to 12 minutes, depending on its size.
Which size of tank is likely to Belve sooner, large or small?
The answer is, small tanks are likely to Belve sooner. Small tanks empty sooner, heat up faster, and with thinner walls, can fail more quickly.
With a severe flame heating tank wall temperatures to 700 degrees Celsius, a small 400-liter tank can Belve in as little as 3 or 4 minutes. A 4,000-liter storage tank can fail in 5 to 7 minutes, and a big 40,000-liter tanker truck can go in 8 to 12 minutes.
Damaged or corroded tanks may Belve sooner, or if the flame is less severe, they may Belve later, by minutes, hours, or even days. Tanks exposed to fire are dangerous, whatever their size. As you see, a tank can Belve at any time, the moment you arrive, or minutes, hours, or days later. And if and when it goes instantly, with absolutely no warning. Don't expect to see bulging or hear pinging noises.
This tank has been deliberately weakened to demonstrate how quickly and without warning a tank can fail.
So rule 1, if you at all suspect that there is a liquefied gas tank exposed to fire, you never go in immediately and try to attack the fire. Firemen have died doing just that. You stay way back until you can size up the situation through binoculars. What is a reasonable distance for emergency responders to approach in assessing a potential Belve situation? This is a key question.
A Belve involving a flammable substance poses 4 main dangers. Fire. Thermal radiation from the fireball. Pressure from the blast. And flying projectiles, with the projectiles being the farthest reaching danger of all.
First, let's look at the fire hazard. If the release is ignited, there's an immediate fireball.
Tests show that when a 400-liter propane tank Belves, the radius of the fireball is about 18 meters. For a 4,000-liter tank, the fireball radius more than doubles to 38 meters. And for a 40,000-liter tank, it more than doubles again to 81 meters. Heat will be radiated in all directions.
A rule of thumb for measuring the danger zone from thermal radiation is this. Firefighters in protective gear and breathing equipment should be no closer than 4 times the radius of the fireball, down to a minimum distance of 90 meters.
For a 400-liter tank, that translates into a minimum observation distance of 90 meters. For a 4,000-liter storage tank, it is 150 meters. And for a 40,000-liter tank, it jumps to 320 meters.
A second hazard, pressure changes due to blast, must also be considered. The danger zone for blast should extend no further than the minimum observation distances for thermal radiation exposure. However, if the released vapor cloud is not ignited immediately, a delayed ignition could cause a violent explosion, and the blast from this is unpredictable and could be far-reaching. The furthest reaching danger by far is flying projectiles. Even at the minimum observation distance to avoid excessive radiation, you can still be exposed to this hazard.
11 tests of induced Bleves of 400-liter tanks scattered projectiles over a wide area. Note the location of primary fragments, including the tank ends and other large pieces. Secondary fragments, such as piping, attachments, and any other objects near the tank, are also a danger. Note that some large projectiles fell far beyond the suggested 90-meter minimum observation zone for a 400-liter tank. One tank end went 230 meters, 13 times the fireball radius. Records show that in one severe case for a similar-sized tank, a projectile rocketed 22 times the fireball radius, about 400 meters. The best point for observation is beyond the minimum distance to avoid excessive radiation. Face onto the side of the tank and with the wind at your back. Even here you can see that some fragments have fallen beyond the observation point.
To sum up, even for a 400-liter tank, the minimum observation distance for firefighters in protective gear is the minimum distance of 90 meters. This is a suggested minimum distance to avoid extreme danger from the blast and thermal radiation. However, remember, at this distance, you can still be hit by projectiles.
Again, for the 4,000-liter tank, the minimum observation distance becomes 150 meters. And for a 40,000-liter tank, it more than doubles again to 320 meters, with the best observation point being broadside to the tank and upwind. For public protection, consider evacuation distances of about 22 times the fireball radius. 400 meters for a 400-liter tank, 800 meters for a 4,000-liter tank, and 1,800 meters for a 40,000-liter tank.
Think about those distances. Even for the 400-liter tank, the minimum observation distance is 90 meters, well beyond the range of your hoses. And even at 90 meters, you could still be hit by a projectile. These distances provide you with some measure of the risks involved, and you should take these into account when you're faced with responding to a fire where liquefied gas is present. Is there any safe way to approach a fire-impinged tank? Definitely not. As we've said, the best position to observe a damaged or fire-impinged tank is upwind and face on to the side of the tank in order to reduce the danger from projectiles and avoid any escaping vapor cloud. But always keep your distance.
Observing with the wind at your back can give you a false sense of security because wind can blow the fire to the other side of the tank, so you may not see it contacting the tank. The tank may burst away from you, but the projectiles can still come in your direction. It's unpredictable.
The fact is, there's no safe way to approach a fire-impinged tank, even in protective gear. If you're looking at a big tank, a tank truck, or a tank car, even a fire truck won't be a big enough shield to protect you.
Is the situation under control if the pressure relief valve is releasing gas? No. Liquefied gas tanks can and do fail even when the PRV is trying to relieve excess pressure. PRVs don't prevent the tank from weakening with heat. In fact, by lowering the liquid level in the tank, they can contribute to the weakening of the steel. PRVs releasing pressure do warn us that something is happening. However, with severe fire exposure, a Belve can occur whether the PRV is open, closed, or cycling.
If the PRV closes, does that mean the tank is empty? No. Remember, even with the PRV closed, there's still pressure in the tank. In rare cases, the PRV could be stuck, and the tank pressure could be very high.
If the flame is contacting only the bottom of the tank, where the tank shell temperature is kept lower by liquid, can the tank still Belve?
Yes, but it may take longer to happen. With a fire on the tank, the situation is always changing. As the fire heats the liquid, the pressure increases.
The PRV opens to relieve the pressure, and the PRV slowly empties the tank. It is doing its job of relieving pressure, but it is also lowering the liquid level in the tank. This can bring flame over the vapor area and possibly cause the tank to fail. Result, a Belve.
Is there a difference if the tank is rolled over on its side? Yes. If the PRV is venting liquid, the tank empties more quickly, so that with a severe fire, it can Belve sooner. Also, the escaping liquid immediately vaporizes and will ignite on contact with flame or spread in a cloud. Can a thermally protected tank Belve? Yes, but it is generally much less likely to. However, if the fire is severe enough, or if the insulation is damaged, the tank wall can be exposed to fire, can heat up unevenly, and could Belve. The message is simple. With a fire-impinged tank, you keep your distance, a long, long distance. Whether the tank is large or small, upright or on its side, insulated or not, whether the PRV is open, closed, or cycling. You can't approach close enough to get water on the tank without getting well into the danger zone. But suppose the fire hasn't reached the tank yet. The flames are getting closer and you want to protect it. What do? Think about it. You can keep the tank cool with water if you can approach close enough to get water on it, and if you have enough water.
But if your fire truck is your only water source, you may not have enough water. A truck carrying 4,500 liters will only provide enough water to keep the tank cool for about 2 to a maximum of 20 minutes, depending on the flow of water and the size of the tank.
Water spray can be effective in keeping a tank cool if the water is applied immediately. However, it requires high volumes of water. For a small 400-liter tank, you need 200 liters a minute. The 4,000-liter storage tank requires 700 liters per minute, and a tanker truck demands 2,000 liters a minute. Just as important, the available water supply should be sufficient to maintain the required volume until the incident is over. Remember, these water volumes are only sufficient to keep steel temperatures at an acceptable level, provided there is no direct flame impingement on the tank. Also, the water must be applied uniformly to cool the tank surface evenly, or you could cause the tank to fail. To get water on that tank, you've got to get your equipment within the maximum effective spray range of 15 to 30 meters. If your water runs out, you'll be deep in the danger zone as the fire starts to heat up the tank, with maybe just a few minutes to get out of there. Conclusion? Unless you have an adequate supply of water, don't even try to protect a tank from approaching flame. You could end up in a trap. If you see steam rising from the tank's surface, get out fast. When is the danger of a Belve over? For a severely weakened tank, the danger is only over when the fire is out and the tank is exhausted of gas. If you see a hole in the tank, you'll know there's no pressure, but then you must watch for gas vapors. So even after the fire is out, avoid approaching the tank and seek expert advice on how to eliminate the remaining hazard. Now, one final thing about Belves. You don't need a fire to have one. Whatever causes a tank to be severely damaged, impact, fatigue, or severe corrosion, a rise in temperature can result in a Belve. A damaged tanker, overturned on the highway and left in the sun for hours, could blow without any fire. To prevent the possibility, the tank should be emptied and/or kept cool before pressures and temperatures can rise in the tank. Again, this is where you contact the experts in handling liquefied gas to get the job done. More about that later. The best way to deal with a potential Belve situation is to try to prepare for it and hence prevent it from happening. Survey sites within your area that store, handle, or use liquefied gas. Familiarize yourself with their safety equipment and water capacities. Time how long it takes to get to any Belve potential sites and assess what you might be able to do in the event of a fire.
Pre-plan your strategies based on knowing your capability for dealing with a potential Belve. Know the size and location of tanks in your area, water supply, volume, duration, capacities of relay units, water volume of monitors, capacities of pumps, available personnel, and backup. Plan observation points for each potential Belve site based on the minimum distances. Assess all areas of risk and develop evacuation plans. Familiarize yourself with tank codes and regulations and report any contraventions. Know how to contact experts in liquefied gases.
You can get expert advice fast by calling Transport Canada's Canadian Transport Emergency Centre, Canutech. Call Collect 613-996-6666. They will provide expert advice quickly over the phone. If needed, they will also contact gas industry experts to help in decision-making on the site. Canutech can also initiate Emergency Response Assistance Plans, ERAP. Finally, keep your eyes open for dangerous tank installations in your area and report them. Any storage or fuel tank placed too close to a building is dangerous and probably illegal. The fact is, your very best response to a potential Belve situation is to prevent one from ever happening.
The Canadian Association of Fire Chiefs and Fire Prevention Canada are pleased to have had the opportunity of participating with Transport Canada in the production of this training aid. It is a significant addition to training material. It provides a realistic summary of procedures that should be followed when first responders are confronted with the presence of pressure liquefied gas, such as propane, at the scene of a fire. Remember, caution is the watchword, prevention is the key.